This is Josh Mandel for another episode of a guided walk through FHIR. This is going to be a double feature. We did a session today already on number 5, looking at distributed resource identification. And we're going to tackle one more topic. Turns out we've already tackled number 6, which is looking at current resource lists. So go back to video number 11 if you want an overview of that topic. And we're going to move on today to talk about number 7. When other systems return HTTP errors from the RESTful API and operations, perhaps using operation outcome, my system checks for them and handles them appropriately. So this is central to clinical safety, is making sure that when you think something has happened, it really has gone off the way that you expect. And this can be particularly important for sharing data. If I think that I've sent you an important piece of information, but actually you threw up an error code, well, there's a gap in my understanding. I might believe that you've received and are now going to take responsibility for some data, but actually you think that you sent me an error explaining that you couldn't receive it. So that'd be a simple example of why this shows up on the safety checklist, because there can be real consequences to that kind of miscommunication. So the way that FHIR works is that FHIR data exchange can happen in a lot of contexts, but we tend to focus on the FHIR REST API. So these are HTTP interactions between clients and servers, where a client is either fetching data from a server or posting data to a server. And the HTTP page of the FHIR spec includes an overview and all the details on that RESTful API. Generally speaking, it supports a set of operations, and the important ones are kind of the CRUD plus S. So create, read, update, delete. It's CRUD plus S for search, which turns out to be one of the most important interactions between a client and a server when it comes to fetching data. So the spec includes all this information in a table, and I'm going to have to zoom out to sort of a regular view to make it all fit. For each of these interactions defined in the specification, we see there's a whole list of different status codes that can result. So what this tells me is if I'm doing a read operation, I could get a status code of 200 or 404 or 410. Those are the things that the FHIR spec sort of calls out explicitly, although it is possible for servers to return additional errors as well. A simple example would be something like a 500 status error where something transient goes wrong on the server. A process crashes due to a programming bug or an out-of-memory error, and the server just has to say, like, this didn't work. So these are not an exclusive list, but these are the specifications, status codes that have some well-defined specific meaning in FHIR. And you'll see the different interactions have somewhat different status codes that they can return. There's certainly a common theme that a status code of 200 is used to indicate that things have worked as expected. But if we dig into it, you can see that, for example, in a create operation, you don't get a 200, you get a 201. And all these things are listed in the FHIR specification under their appropriate operations as they're defined sort of earlier up on this page. And, if you want to learn more about why a 201 is used in the context of creating a resource, you can get into the context there, which says what happens when a create successfully leads to the creation of a new resource on a FHIR server. You get a 201 response, and you get this shall include a location header. So this is the general pattern if my create attempt kind of works. So how are these error status codes defined? We can just take a look at Mozilla Developer Network is a great resource for understanding more about these specific status codes. So in the underlying HTTP specifications, 201 is defined as being used for a created response. And so it makes sense that in the FHIR HTTP page, that's what you see here documented. The spec is built on top of HTTP and the conventions from HTTP. So anytime you create something, you're also going to get this location header that tells you where it is. Where is this new thing that has been created? And so typically you'll get back the base URL of the server / type. So if I created a patient, this might say my server URL /patient/123. And you'll see that this location header includes not just the fact that I've created patient 123, but also points to a specific version of patient 123. So if this is the first time it's being created, this might say something like /_history/0 or 1, or whatever the server's convention might be for assigning an initial version ID. That said, not every server supports versions, and so there's some additional language down here that you need to read before you turn this into a regular expression and embed it in your code. So what we say is, if a server doesn't track versions, the location header will just contain base/type/ID. So it's a little misleading to see this up here. You actually have to read ahead to understand the full range of values that might show up in this header. Think about this last part here as kind of an optional bit at the end. So that's all the happy path. That's what happens when things go well. But what about when things do not go well? In the context of a create, we've got a few conditions where things could go wrong. We say 400, bad request. This might be the error that gets returned if the resource that you asked the server to create was invalid. So maybe you passed along some JSON snippet, but you did your JSON serialization wrong, and the server wasn't able to parse it. Maybe you're trying to submit a patient into a server that only manages FHIR practitioners, right? Maybe you're trying to write this information into a provider directory server that doesn't manage patients at all. And so there is no patient endpoint. You might get a 404 error. Or, this is a pretty broad catch-all category, 422, unprocessable entity. And what we say here is the proposed resource violated applicable FHIR profiles or server business rules. This should be accompanied by an operation outcome. So the server has some rules. Maybe they were communicated up front and clients should have known it. Maybe this is the first time the client is learning about those rules and it's going to have to make some adjustments on the fly. But getting an error status code of 422 is at the very least an indication to the client that something went wrong. And when that happens, the client is not going to get a location header pointing to the newly created thing. Instead, hopefully the client will get directly in the HTTP response body a resource that FHIR calls the operation outcome. And this is a resource that's designed to communicate sort of what happened as a result of an attempted operation. It's typically used for things like communicating errors or warnings, but it can also be used to convey any kind of information about the outcome of some interaction between systems. And an operation outcome is basically a list of issues, and each issue has a severity indicating how bad it was, anything from information to warning to error to fatal, and a code indicating what went wrong or what is the information about. The text here is a little bit off. It says error or warning code, but since an operation outcome issue might just be informational, this text really should say code describing the issue. And if we dig into the long definition here, this is actually better. It describes the type of issue. So the short definition, in its succinctness, doesn't quite cover the whole space here, but gives you a pretty good sense of what's going on. All right, so you get an operation outcome back when something goes wrong, and at the very least, this might include some human-readable diagnostic information in the form of a string here. It might have some codified information, maybe a list of detailed codes about what went wrong, and that's about the size of it. So operation outcomes are something that clients should be aware of, especially when you get an error response status code. So each of these operations, interactions in FHIR has its own set of different response codes that could apply. But the general rule is the client that's making a call needs to be on the lookout for things that start with a 4 or things that start with a 5. Those are generally the status codes that indicate something went wrong here. And when that happens, the client needs to be prepared to take corrective action. And depending on the code or depending on the error, the corrective action might be different. With a 500 status code, that might just be an indication to the client to say something went transiently wrong. The server was having a bad millisecond, but if you try again, it could work. On the other hand, if you see a status code indicating that the endpoint doesn't exist or that your payload was malformed, just trying again is probably not a good strategy because your payload is probably still malformed unless you can correct the error. So that's a bit about these error response codes. There's a lot of them. It's actually worth looking through the spec and reading about all the different things that can go right or the different things that can go wrong. Let's also look at the second point of the safety checklist, which was not just errors from the RESTful API, but also errors from operations. And so FHIR provides this framework called the operations framework, which sort of goes beyond the basic CRUD or CRUD's functionality of the REST API. It goes beyond just creating, reading, updating, deleting into doing new stuff, additional things that are maybe more interesting or more complex or involve more specific business rules. You could think about this operations framework, I tend to think of it as a kind of an RPC, remote procedure call capability that's built into FHIR. And the idea is a FHIR server can support any number of operations using this operations framework. And clients can call an operation by passing in inputs, and then the server can process the data and respond by passing outputs back to the client. And if I look at operation definition, this is a way to describe very specifically what kinds of inputs and outputs your operation requires. So when you're defining an operation in FHIR, you give it a name and other kinds of publication metadata. Who published it? Is it a draft or is it a finalized status of an operation? And then you provide a list of parameters. These can be input parameters or output parameters. So that's this use field here. So I can say, I'm going to create an operation called member match, might be an example from the Da Vinci specifications. And there might be an input operation that takes a patient resource representing a member of a health plan. And then it might provide an output representing any known identifiers or a patient resource in the target system that matched the request. And under the hood, the logic for doing a match might be quite complex. It might involve probabilistic matching. It could even involve an asynchronous review step where a member of the back office staff is going to get involved and take a look and sign off on the results. There can be a lot of interesting things happening in the operation. But an operation is fundamentally defined by the inputs and outputs that it uses, plus a description of what is supposed to happen in the black box in the middle. So you can list all of the parameters that you need in your operation using any of the available FHIR data types. And so each parameter has a type, which can be a data type or even a FHIR resource. And so when a client is calling an operation, the input to that operation is a parameters resource. So this supplies basically a bunch of name-value pairs. Each parameter is named, and you'll go back to the operation definition to know what the names should be for inputs. And then each parameter has either a value, which could be anything from a value string, or a value datetime, or a value boolean, any of the FHIR data types. Or if you need to embed an entire FHIR resource, you can also do that using parameter.resource. And so you can shape all the inputs to your operation using this parameters structure, and then the server turns the crank. The calculations inside that black box proceed, and at the end, typically what you'll get is an output, which will be a parameters resource if there's multiple outputs, or it could be some very specific resource, like if you're doing an operation that might always produce a bundle, or it might always produce a patient resource or a measure report. Those would be examples of operations that just return a single FHIR resource out. But either way, if the operation succeeds, you'll get the specified output that you expect. That's all well and good. But of course, what happens when the operation fails? What happens when something goes wrong? So let's take a look for a minute at the operation response section here, because this is what the safety checklist is pointed to most directly. What we say is if an operation succeeds, we use an HTTP success status code, typically something in the 200 family. That's what 2XX is indicating here. Although it could also be a link to content that's hosted elsewhere, so that might be a 303. But if you get a status code like in the 400s or 500s, that indicates an error. There should be an operation outcome in the response body, just as we had for the REST API. And so the same basic conventions that a client is going to follow in that CRUD API, those same basic conventions should apply here too. In general, a client should not be firing off a request and ignoring the response. Very important to look at the response and make sure that things work the way that you expected. So that covers the REST API, operations, and operation outcomes. And with that, we'll wrap it up and pick up again next time.